My name is Christian Greer, and I'm the Chief Officer for Science, Education, and Experience at the St. Louis Science Center. I've had the pleasure of working with the group from Maxwell team. Actually, we had John McDonnell, who serves on our board, have a special event in which we dedicated a plaque to this distinguished group at the Science Center. I believe it was maybe 2 years ago even. It's on display if you had a chance to see the Mercury and Gemini capsules that we have on display that are on loan from the Smithsonian Air and Space Museum. You've had a chance perhaps by the Planetarium to see the plaque that is dedicated in their honor. We are very excited to have these gentlemen here. We're running a little bit behind schedule, so I'm going to try to keep my remarks as brief as possible and get us into the program. Let me first just say that two years ago, the Science Center became a Smithsonian affiliate, and it's afforded us with the opportunity to tap into the brain trust, the resources, the amazing collection of historic objects that the Smithsonian has to offer. Next year, the Apollo 11 command module, known as Columbia, will leave the Air and Space Museum in Washington, D.C. to travel the country. This will be the first time since the early 70s that the capsule has left D.C. We are one of only 4 organizations in the country to have it on exhibition, and it will start on April 14th of next year. So it's an incredible opportunity for us to connect the people of the St. Louis region to a very important part of aviation and space history. But before there was an Apollo program, there was a Mercury and Gemini program that started right here in St. Louis. So it's a bit of pride for us here in St. Louis. And we are fortunate to have 6 members of Maxwell team with us this morning to talk about the programs and share some of their stories. And they've got a lot of stories. Maxwell team is an ad hoc group of retired employees from McDonnell Douglas, St. Louis, and Boeing St. Louis. Most worked in missiles in space, with some in aircraft. They are very proud of their heritage of being Mr. Mac's teammates, and they remember the days of "This is old Mac calling all the team," which was a message that went out over the PA system to the team, helped build camaraderie and to focus their efforts. But first, who was Mr. Mac? James S. McDonnell founded J.S. McDonnell and Associates in Milwaukee, Wisconsin in 1928 to produce a personal aircraft for family use. The economic depression of 1929 ruined his plans, and the company collapsed. He then went to go work for Glenn L. Martin. He left in 1938 again to form his own company, McDonnell Aircraft Corporation, based in St. Louis in 1939. McDonnell is an aviation pioneer, visionary founder of McDonnell Aircraft Corporation, and left an indelible stamp on his industry and in St. Louis. Among the first university-trained aeronautical engineers, he was a powerful advocate for excellence in teaching and research. Mr. Mac, as he was known, served at Washington University as a trustee board chair in the 1960s until his death in 1980. The company Mr. Mac founded in 1939, as well as its successor corporation, enjoyed success because he anticipated the manned space exploration and insisted on the highest standards in engineering and technology. McDonnell Douglas products figure prominently in space history with the Mercury and Gemini programs, and also with legendary fighter planes like the F-4 Phantom and the F-15 Eagle. James S. McDonnell believed that science and technology gives us the unprecedented power to shape the future and oblige us to direct our intellectual, social, and cultural development responsibly. In 1963, he wrote, "As man recognizes his responsibilities and moves ahead to carve his own destiny, there will be many problems to solve." And I think up here with us today are a lot of problem solvers. And so let's give them a big round of applause here. I'm going to start off by having them just quickly introduce themselves. And, I don't know if this applies, but when John McDonnell had an opportunity to go around and interview each member of Maxwell team, they all remembered their employee numbers, I think, that we had talked a little bit about. And so they're going to impress you, I think, with that as they introduce themselves. If you could give us your name, your employee number, and tell us a little bit about what you did. I'll start with the gentleman closest to me.
Okay, I'm Earl Robb, and my badge number is 39950. That's Mr. Mack's number.
Earl, what did you do? What systems did you work on when you worked for Mr. Mack?
I worked on, when I first came there, straight out of college, I worked on jet airplanes and commercial airplanes for about 4 years, perhaps 5. And then I was shifted over to work on space programs, and so I started my space activity in 56, 57 with the Mercury program. And I was real lucky because I was able to be in a group of engineers that developed the configuration for that. Now, I just have to say this, I was pretty young, so I didn't know much at that point. But I learned a whole lot from Mr. Mack's team, and the best thing in my life.
Great. Well, thank you very much.
And then after that, I did Gemini. And then after that, I did Skylab.
Ah.
Okay.
See, they're just kind of like this. So it's just the first guy, you know. Let's get through these. Okay, let's go up next.
Yeah, I'm Norman Beckel, and I came to work for McDonnell Aircraft at that time in 1958, and worked on the Phantom, the F-4 Phantom, and then the next year, we were awarded the Mercury contract, and so they developed an astronautics division, and I was fortunate enough to land in the astronautic division. My area was avionics, and we, on the spacecraft, Mercury and Gemini, we had voice communications, and we had radar tracking beacons and telemetry transmitters and other beacons on there. And that's my story. I'll stick to it.
Your badge number?
Oh, 85853. They gave me an easy one to remember.
This is amazing. You know, I don't think I can remember my phone number now that I've got a smartphone in my hand. All right. Well, thank you, Norman. Let's go to our next guest.
My name's Bob Shep. I started at McDonnell Aircraft in 1956. I attended Washington University for about 2.5 years, then went off to work at a company as a technician. And so I went to school during the day and worked a second shift at night. Took me a little while because I had to limit my hours to about 12 instead of 16. And so at nighttime, my job was to pre-flight all of the fighter airplanes so that the next day, the flight test guys could fly the planes. And so my expertise became the autopilot. And so we had the Century Series airplanes at the time called the 101 Voodoo and the F-3H in the Navy side. So when I got out of school in 1959, the Mercury program was starting, and since I had autopilot experience, he says, well, you're going to go get on the Mercury program and keep the autopilot working. So that's what I did. And I worked on the autopilot for the Mercury, and then I came back to St. Louis and helped design the orbital maneuvering system, which was one of the most important systems in the whole world because that's how we got to the moon. And worked on that for a while, and then I became the person that helped get the even-numbered Gemini spaceships through our launch operations. So I had all the even-number ones, and that's when I got to meet Neil Armstrong and all those other neat guys that were part of the space program.
Incredible. Bob, did you give us your
my
number?
badge
What's
number,
yours?
63124.
Those that are taking note. All right, next up.
I'm Dean Purdy. I started with McDonnell Aircraft in 1955, right out of school. Badge number was 59283, and I was very fortunate to work on some really what to me were very interesting, exciting, even historic programs, starting with one Mach 2 jet fighter, which was the F-4, and then 3 missile programs, 8 space programs that included 5 of our nation's manned space programs, starting with Mercury, Gemini, Manned Orbiting Laboratory, Space Shuttle, and Space Station over a nearly 40-year career. So very fortunate.
Incredible. Thank you, Dean. And last but not least.
Hi, my name is Jerry Roberts, and I was recruited right out of college and went to work for McDonald's directly on the Mercury program. There my specialty is the guidance and control area, and that's my entire career was in that. And I'm sorry we couldn't find you people earlier this morning, but we.
Yeah, I was going to ask about that.
My gyros and Bob's autopilot just didn't work right. But I went through, my badge number is 91690, but I went through the initial design development of the Mercury here, and then Bob and I and Norm, they didn't mention it, but we all went to the Cape and were on the launch crew in the blockhouse. So we went through the Mercury program, and then we did recycle back to St. Louis and did the same thing through the Gemini program. Now Mercury just had a stabilization and control system, but Gemini had the world's first full-blown guidance and control system that was small enough that you could put the computer and the rest of the hardware in the spacecraft. And I know you've seen these spacecraft; they aren't very big, so we had to fit them in. It was kind of a tough deal, but it worked. Our people are always interested in well, you had a computer in there. How big was it? Well, memory-wise, we had 4K. That's it. And we had a tape deck to reload it, but we did the launch, the rendezvous, the docking, orbit change, everything in Gemini with that small computer. So I look at it today and I said, I would almost say it couldn't be done, but we did it.
Jared, did we get your badge number?
91690.
And this is amazing. I think when we went around, we had many more people from Maxwell team that were in the planetarium where you were yesterday in the Star Bay, and I think one guy said his badge number was like 2 or something. I can't remember who it was. It was started in 1947, I believe. So, you know, we have an incredible history and legacy that these guys have started that were passed to them and that they're passing on to the next generation. I know we have at least one on our staff as a Boeing engineer that's working in the space program on the next generation space capsule, is one of our staff at the Science Center that operates our planetarium. I've got a bunch of questions, and we're going to kind of fire through these as best we can. And let's keep in mind, when you hear these answers, this isn't sort of the History Channel version where you just kind of get the top line of what has happened in the space program with a couple of video clips you've seen 1,000 times before. These are the guys that were there helping to make it happen. And it's not without error and trial and a little bit of overcoming using the engineer's mind and mindset. So let's start off with the Mercury capsule itself. And this is kind of open to each of our panelists up here. How did Mercury come to be?
Well, it was a hard birth. Let's see. We were given the envelope, the outside envelope, and actually the diameter was dictated by the diameter of the fuel tank on the Atlas missile. Because we used the Atlas, the Titan, and the Redstone, and basically we took the warhead off and put our capsule on there, so that pretty well set it. The rest of the configuration is dictated by the re-entry. You know, as you come in, you have to have the blunt end forward, of course. And but Earl can tell you, he did a lot of the exterior and interior structural design, and that's something that we had to invent. We didn't invent many things on Mercury because we didn't have time, but Earl did.
Where did the Mercury come from? Was the question, right?
Yep.
I think it came from Mr. Mack. Pure and simple. Back in the 1950s, we were having satellites up in the air, in the sky, and the Russians were checking on us, and we were checking on them. And Mr. Mack, he has a long vision attitude on everything. He concluded that there should be a man in space. And so I believe it would be fair to say in about 1956, he had his top team working on putting a man in space. Well, why was he doing that? Well, I think it was pretty simple. We needed a man in space to support the activity that was going on between us and Russia.
Well, you know, the real bottom line was we were afraid they were going to develop a orbital bomber.
Yeah.
And so we had to catch up fast because we need to have an orbital bomber also. It was a back and forth thing going with the Russians. So it was called the Cold War, and that was the incentive to get us up into space. Yeah. Once that Sputnik went around, that was the red flag. We got to get going. We never. I think I worked on a proposal for a manned orbiting bomber, but at that time the NASA took over all manned space programs, and the military was taken out, and so then that program went away.
Mr. Mack had started the program, as Earl said, in 1956, quite some time before Russia's Sputnik was launched. So he was a man of vision, and he knew what was coming. So good leader.
Well, when the Russians launched Gagarin, the first man in space there, particularly in orbit, we went on 18-hour days, 7-day weeks to try to catch up. We were designing this thing in the view, the whole world was looking on. So it was a development program, but any mistake we made, anything that blew up, anything that was, it was a misfortune, but everybody knew it. We found out years later that Russia killed many people to get Gagarin into orbit. We, of course, would not do that, and it took us longer, but not much. We were right behind them, and of course, we overtook them.
So when Sputnik went to orbit, beeping that little signal, what was on your minds? Where were you? What were you thinking? Were you working for the company at that time? What was the fallout from that? Was it a challenge to you? Did you kind of take it personally? Thoughts?
I was too busy being an engineer doing autopilots. I wasn't worried about Mr. Sputnik. So later on, we got to worry. And Jerry was right when they launched Gagarin. We were on that schedule. Those are called scheduled hours. 18-hour days, 7 days a week. We did that for about 2.5 years. And it's a good thing we were young and could do that thing. When we launched John Glenn, we had 3 scrubs, and we went 3 straight nights without any sleep. And
well, there were 300 of us, young engineers, that went to the Cape with the first Mercury program, and of that group, one of the human factors agency guys calculated 48% got divorced. Because the men weren't home. The women raised everything. So they need the commendation, the women, for putting up with us to do that.
Yeah.
Well, let's see. When Sputnik went up, I was in college, and I was a late bloomer, having served in the military and then went to college. But when Sputnik went up, it caused a great deal of consternation within, because at that time, as Earl, I think, had previously mentioned, we were in a Cold War with the Russians, We were developing intercontinental ballistic missiles to carry warheads there, and they were developing intercontinental ballistic missiles to carry warheads here. And so there was not exactly a fear around the nation, but there was a lot of consternation when that Sputnik went up. And we tried to follow that fairly with a program called Vanguard, a Navy missile. And it got maybe 10 feet off the ground and then fell back to the pad. And we were really concerned then. And so we did a lot of catching up. They put the first man into orbit in Yuri Gagarin. And a year or so before we were able to launch, and our first man was Alan Shepard on a ballistic flight. Of course, we don't know what went on in Russia because, like somebody said, the United States, being who we are, we did things out in the open. So when we committed, when something bad happened, everybody knew about it. And so it was a serious time. When we went down to the Cape, they were developing like the Atlas and the Titan and the Minuteman and I don't know, Polaris. And it was like a fireworks every week. We saw a missile launched and destructed, and the newspapers were filled with headlines. This ain't gonna work. You can't put a man, you can't even get these things off the ground, let alone put a man on it. And so that's some of the background of where we were at that time when we started on the Mercury program.
I'll tell you an interesting story. Jerry Roberts and I, we arrived at the Cape at the same time, and you had to go through this big program of getting your Cape badge. And so when we got to the office, this is our first day of work. So when we got to the office, he said, hey, you guys, go back to Titusville and get your license plates. Because if you come down here tomorrow with the Missouri plate, you'll get a ticket. So we hadn't been at work 15 minutes, so we were driving back to Titusville. It was 25 miles. And we get to the North Gate, and the guard says, hey, you guys, it's T-minus 3 minutes for that Titan II over there. Oh, okay, we'll watch it. So it gets down to 0 and lifts off. It goes past the top of the gantry and headed towards Titusville, and they blew it up. And we said, what in heaven's name have we got ourselves into here? But then, and Norman's right, about every month one would blow up. And there's all kinds of reasons for that, but that's the way it was down there.
Well, as engineers, you have to design things to certain specifications, and you're taking on a very challenging project, doing things that had never been done before. Did you ever get a spec that you kind of looked at the person handing it to you and said, "The hell are you thinking?"
Yeah.
Hey, I tell you, one of the problems you mentioned, we had a spec to design things to. I guess the basic answer is no, we didn't.
Yeah.
We were trying to do something that had never been done in the history of mankind. We initially were told by the medical community that a human probably wouldn't live if 2 hours in a weightless condition. There were all types of things, the radiation belts, all the stuff that is so common now. We didn't know. We didn't have any information at all on that. We just had to try and see what worked. And as Bob said, we did it in front of the world, and so when we made a mistake, or when what we were trying to do failed, the whole world knew it instantly.
The autopilots came out of one of the fighter aircraft. The only difference is in the fighter aircraft, the signals went to a servo mechanism hydraulic actuator to move the control surfaces. In our case, we just sent a signal to a little solenoid, and it squirted hydrogen peroxide on platinum, and out came steam. One of the first chemical reactions we talk about when you're going through chemistry. So a little spurt of steam came out, and that's how we control the attitude of the Mercury spaceship.
Now, in terms of the systems integration, you all worked on different systems. How did you work with other engineers to integrate those systems, especially when everything is so new?
we had to integrate astronauts with those systems. The way NASA divided it up, that each astronaut was given a system to be responsible for, and so they would get with the systems guys and learn about it. I think John Glenn had the Atlas one, and Jerry and Gus Grissom had our autopilot. So Jerry was always putting me on second shift. I worked 6:30 at night till 6:30 in the morning. So
See,
there was-
Bob assumed I was his boss, but I wasn't really.
so,
The art
So-
of
Have
delegation.
boss. We had-
late at night,
It was like-
when we were doing things, Gus and I'd have some spare time, and then so I'd sit and teach him how the autopilot worked. That was my first teaching job. I am still teaching, by the way, at age 83, and I consider the young people our future, and so I teach 6 through 12 in 2 school districts, and I really promote space, and well, my goal is to get those guys to be the best they can be, and so I guess I'll keep doing it until they can't get there anymore.
Well, you know, as someone who's not a pilot, I'd be happy to be able to flip that switch and have the autopilot take over. But you've got some very experienced test pilots as astronauts. So was there any challenge with that? You know?
Gus Grissom wanted rudder pedals in this thing, and he almost got them. But they had a lot of input, and they were like rock stars when they were away from work.
Yeah.
And most of the things that the suggestions they made had merit because they were all engineers. But some things they like the rudder pedals. We had to come to some kind of a conclusion, and the meetings usually were closed door and kind of difficult. Because when they left the Cape, they literally were rock stars. I mean, they were mobbed, and so they felt like that since they were going to ride this thing, they could design it, and they have gotten over the years credit for some of that design. The actual vehicle was modified a little bit because in the spacesuit it's hard to flip switches, but you have to keep in mind back then in the Mercury we didn't have anything but switches and meters and lights. We designed this thing with a slide rule, and we had no transistors, we had no any input except for what I call really manual systems today. And I don't know, looking thing, I don't know if I'd go up in it again or not. But
Let me put in my little famous story, Jerry, and my big peeve with the good old Facebook. When the astronauts, Jerry was right, that they were the rock stars, and they did have inputs. They came from flight test centers all around the country, 70 of them, and they picked the 7 guys. So they were the top drawer test pilots. And so they wanted to fly frontwards. And so we argued with them for weeks. No, you can't do it. Because the way our autopilot worked, we had a vertical gyro. That's what they call a vertical reference. And it always pointed at the Earth as it went around. And so we put a signal in and made it do that. And so it went 4 degrees a minute because 360 degrees and got around the Earth in 90 minutes. And so they said, no, we want to go forward. I mean, we're not going to go around like the chimpanzees backwards. So we had a purpose for going around backwards. We didn't know what was going to happen to those guys when they were orbiting. And so while they're going around backwards, we had to retrofire fast. We wanted them to be pointing in the right direction. So we lost, and we had to put a switch in the spacecraft cockpit and some circuits in the autopilot to torque the thing in a different direction when they were going around frontwards. So, you know, you had to be in that era. Astronauts never made mistakes. And even to this day, they're broadcasting over, I guess it's YouTube, they're broadcasting over YouTube that the autopilot in John Glenn's flight failed and he had to fly by wire. Yeah, right. They got that one.
I told you this was not the History Channel version. This is the real deal.
So what happened is shortly after the spacecraft separated and he was into orbit and everything stabilized, all our indicators were reading 0 on the autopilot, he said, okay, I'm going to go frontwards. So he turns around, goes frontwards. And in 4 minutes, I knew what he did. He turns around, and so because he was moving the nose of the spacecraft forward, we were torquing in the wrong direction, so it was changing at 8 degrees a minute. In 4 minutes, he had minus 32 on his attitude indicator. And he calls down and says, well, the autopilot's acting up. And so then the next thing that happened, we had another reference system on the spacecraft called the Horizon Scanners. And they were mounted right at the center line of the spaceship. And they looked at the horizon, and that was another 0 reference. And we didn't run them all the time because they'd used a lot of power. But they came on and started torquing it back. That's all it took. He shut the autopilot off. So he flew the entire mission fly-by-wire. Now we have an anomaly. The spacecraft is broke, right? So when he gets back and gets through all of his, his ticker tape parade and visiting the president, and he came to our lab, and we were 5 guys, right, Jerry? And 5 guys in our autopilot group. Nobody wanted to tell him what he did. So we drew straws, and I ended up with the short straw.
Right.
So he came in, and we had a little simulator in our lab, and I worked on that thing for a week trying to duplicate exactly what he did. And you just can't come in and say, well, you forgot to throw that switch. And he'd say, no, I didn't, I did. So we were standing there, and I started the simulation for him, and when I got done, he says, Bob, he says, my goodness, he says, that's exactly what I saw. Now, how am I going to tell him? But he gave me a perfect opening. He said, what in heaven's name could have caused that? And I said, well, that little switch right there, and I had it in an off position, that little switch right up there. And then he said, oh my God, I forgot to turn that switch on. So that was a real proud time in my life because I didn't know how I was going to do that job. But he admitted to it, and then that solved the problem. And the rest of the astronauts, they remembered to put the switch forward. And now that YouTube is running around saying that my autopilot was broke, So when the guys
So that means go to the comment sections, guys. Tell them you met them. And fire back, all right? Okay, let's keep with the astronaut engineer interface stories. So any cool stories that you guys want to tell about working with the astronauts and your systems?
Oh, I got a lot of
I'll give you a try.
Well, I tell you, I like to tell the one about Gordon Cooper. Oh, I'm sorry.
You gotta go first.
You okay now?
Yeah.
I'm a designer type, okay? And so early in the activity of design, I had little or no contact with the astronauts. After the design was made known and so forth, then I had a lot of complaints about the design and so forth. One little example, these guys have heard it 100 times, but I worked on the structure, and one day when what's his name, Gus Grissom came in on a design review, and we were at that time working on the elements of EVA and so forth, and how the astronauts can make money. No, how the astronauts can work it, and in this particular case, Gus Grissom, I was walking Gus Grissom around to our activity, and to show him how he could get to a certain element to work on it out of space.
It's on the Gemini program, right?
So he so we got to this point, and Gus, and I have to tell you this, Gus was, I loved him. He was my favorite because he's kind of like me. He's very hard-headed, and he disagreed with the item, and so we debated it about, and so he finally said, I want you to get on a spacesuit and see how it really works, you know. He says, you got to understand that, you know. Well, I had already done that. Illegally, I might add. So I said, okay, Gus. I said, I'll take care of that. So he said, I want you to get on the spacesuit, and I said, okay. So we go on through the day on activity, and right in the early afternoon, I got a call from Mr. Mack's office. It was his secretary. She said, you've got to go down to the astronaut room and put the spacesuit on, you know. And Mr. Mack wants you to do that right now, you know. Well, so I went down again, and so forth. So my point here is that Mr. Mack was very complex and detail-wise, and he checks on everything. And he reviewed with all of the astronauts when they would be in. He would be the first man to review with those people and check it out. So that's my story. I got the job
Sticking
done.
to it, right?
I got the job done, but I'd already done it.
I like that. Norm, what were your reflections on working with some of the astronauts?
Well, like somebody said, each one of them had expertise, or at least were assigned. And John Glenn was assigned to the communication system, so we worked with him quite a bit, and they were very, like Earl said, very detail-oriented, very easy to get along with, very inquisitive. Had a lot of questions, and so they were searching for knowledge, because when all was said and done, they were the ones that would get in this can of bolts and nuts and be launched. When Glenn was launched on the first Mercury flight, Scott Carpenter was the capsule communicator in the blockhouse, and he happened to be sitting beside me. And when he was launched, his famous words were, "Godspeed, John Glenn," and those were recorded. Before that, while the umbilical was still attached and we were on intercom, he said, "John, did you ever think that this was built by the low bidders?" That's sort of a little icebreaker, I guess. But one of the things on this design of this spacecraft, and this is where Earl's came in, the predominant driver was weight. You could only lift so much. And so everything was weight driven. Our boxes, in the communications area, we took boxes from like this size in the airplanes down to 6 inches by 3 inches by 2 inches. And so this miniaturization was in its infinite stage, and we did have some transistors in our electronics. We weren't yet to the point where you could get much power out, So the output stages were still vacuum tubes. But the technology at that time was going, I mean, it wasn't advancing in years, it was advancing in months. I mean, it was whirling. And we went from very few solid state in Mercury to a lot of solid state in the Gemini spacecraft. We went to digital command systems where we didn't need all that wiring. We had miles and miles of wiring and switches, relays on Mercury. And so getting some of the things that were done, like on our transmitters, they made a decision. I didn't make it, it was made before me, to take the ferrite buffers out of the output stages of the transmitter. And so as a result, if you had any mismatch on the antennas or anything, or if you tried testing it on a bench and didn't have a perfect load on it, you blew the output stage of the transmitter. And so that was, you know, one of those things where we saved probably 5 grams and cost us a lot of transmitters on the ground. They all worked once we got in space. But it was a learning curve. I mean, the whole nation was in a learning curve. I said we were trying to catch up, and all these technologies had to come together. And so by the time we got to Apollo, and based on today's, my friend's iPhone just went off here. There's more computing power in that thing than we ever dreamt of, even in Apollo. So all these things, we were there at a very good time in our nation's history, where technology and the desire to beat the Russians sort of came together.
Well, you know, you think about spaceflight, and what comes to mind for me is the most sophisticated technology you could imagine. But in these timescales, of which you have to rapidly turn around, I can imagine you found some pretty low-cost, simple solutions to solve problems. Can you talk to us a little bit about that?
We were still on analog. We didn't have Wi-Fi yet, guys. Mr. Tucker is not here. His responsibility was for getting all of the cabling changed after each launch, and they were wanting to turn around very fast. So he had a tough job. He would work 3 or 4 or 5 days in a row. But we had to be within 400 foot of the launch site, because in analog systems you have voltage drops. So by the time, if we got way back there, we wouldn't be able to recognize what the signal was. So what that did for us, though, is all the cables got burned up. And so his job was to replace them and make sure they went to the right place and get us ready for the next launch. And today, all those signals get sent to us by Wi-Fi. So that's the change, you know. We were basically an analog system.
Well, that's why we had to have such a structural blockhouse to launch these dudes.
Yeah.
The blockhouse roll is still there at the old Cape Canaveral Air Force Station, and that we had literally 8 foot of concrete over us, because, as Bob said, we had to be that close to the vehicle, or we couldn't initialize it. We couldn't prepare it for orbit. You couldn't get a signal for it. Seems kind of quaint now, but that sucker was a Model T. It really was. Yeah.
Other thoughts?
Do you have any stories for astronauts?
Stories for astronauts. I was at St. Louis most of the time. Many flights down to the Cape during the Mercury program, Gemini program, but I was not a part of the launch crew like Norm and Bob and Jerry were. But I did work quite closely with Alan Shepard prior to Wally Schirra's flight and also Gordon Cooper's flight. Norm mentioned how critical weight was on the spacecraft because at the time there was only, time of Mercury, when Mercury started, there was only one operational missile launch vehicle that was in the U.S. arsenal, and that was the Redstone. The Atlas was under development, but we had to watch weight very carefully, and there was a lot of stuff inside that Mercury capsule. But for Shiraz's flight and for Cooper's flight, which were longer flights, Glenn's and Carpenter's flights were 4.5-hour flights. Shiraz was like 9 hours, and I think Cooper's was 34 hours. 22 orbits, 34 hours.
34 hours, yeah.
So we had to install in the spacecraft additional water, additional power, batteries, additional fuel, that kind of thing, and everything was inside the spacecraft on Mercury. But there were two ways of getting out of the spacecraft. One was the explosive hatch, and one was a hatch in the nose of the spacecraft. And in order to get out of the nose of the spacecraft, they had to disconnect a portion of the instrument panel, fold it back, and so on. Well, where were we going to put all this new stuff, all this additional stuff to be able to have these longer flights? And so Alan Shepard was assigned the task of coming in and working on the mock-up in St. Louis, and we would install this new equipment, and then he had to make sure that he could still get out through the hatch if he had to, or up through the nose hatch in the spacecraft. And that was difficult even without this extra equipment. So he would come in and put on his suit, helmet, go through the procedure, and he would say, can't do it. You got to move that stuff. So we would have to move it around until he was able to get up through that hatch. And believe me, he worked hard at that. I would bet that he lost 5-10 pounds in sweat just trying to get up that his suit was just wringing wet with sweat when he would go through this. But we eventually got all that stuff in there, and we had very successful flights, but had to work pretty hard to do it. It's interesting about the weight problems that we had on the spacecraft. I think the Redstone had something like 78,000 pound thrust. It was a suborbital flight for the Mercury. Atlas, when it came along, was about 300,000 pounds. And we talked about Gagarin. His first flight was a full orbit. Ours was 15 minutes. His Vostok launch vehicle had over 800,000 pound thrust. And throughout the Mercury and Gemini program, we never had anything more than about 430,000 pound thrust. So Russia had a great advantage in the early programs because of their ability to launch much heavier loads than we could.
Yeah, they made their spacecraft extra thick so they could pressurize at 14 pounds per square inch. We used 5 pounds per square inch of 100% oxygen.
Yeah.
So, but that thing had a rough landing. It was spherical shaped. And so when it get down and land on the ground, it kind of got drug along. And so we found out later in life that Gagarin really bailed out at 25 feet,
yeah.
25,000 feet, and came down on a parachute.
Yeah.
So they didn't like the landing either.
Well, lots of great stories. I mean, I'm sure these gentlemen could go on forever, but as you're sitting here listening to this, I know you're just brewing with questions that you have. We're nearing the end of our time, so this would be a good time for you to conjure up some of those questions and ideas that you have from Maxwell team, and they'll respond to them as we go. We'll see one hand over here. Anybody else? A couple over there, some in the middle. All right, we'll try to get around to you. If you stand up in the back and you can just project, that'll be great, but I also have a microphone in case you need it.
stuff that had never been done before. And when we build things today, we always second guess ourselves. There's always that self-doubt. Is this the right design? Is this the best way I can do it? Should I go back and try it again? There's always that voice in the back of your head.
Did I do this correctly? And if you guys could for a moment, what advice would you give for those of us who aren't doing things this grand? What did you tell yourself? What was your internal dialogue where this is a good design, or I'm happy with this design, or I think this could work?
Easy answer to that.
We didn't do anything.
We don't let it happen on your watch. I'm as facetious, but I'm serious about that. We did everything that was humanly possible to not harm an astronaut. I don't know what would have happened had we lost one there. But well, they hated to admit it, but the Mercury spacecraft we designed for a disabled astronaut. If we didn't know whether he could live in space or not, but if he was not able to do anything, he could cross his arms and come home. Gemini was a little more difficult, and of course Apollo was way more difficult. But that was the approach. You know, every machine designed by man has a failure point. So try to design so that failure point is after whatever has to be done, or whatever the machine has to do has been performed. You know, after he's up there and comes back down, we don't care if he blows a hole in his suit, but don't let it happen while he needs it. And then basically that was our attitude.
You got another question over here.
Design it well, and then test the heck out of it at levels well above what you expect.
And we didn't do really much designing, like the autopilot came out of an airplane.
Yeah.
So
We didn't have time.
Didn't have time to do that kind of stuff. So yeah, we didn't do a lot of designing, but we checked the heck out of it to make sure it would work and do what it could do in the first place. There's another interesting story you're an engineer, so you've heard of reliability groups. Those are the guys that study how something's going to work and whether it'll meet the perfect reliability is one. When you take statistics in school, you get involved with all that stuff about the chance of you getting a 6 when you're throwing the dice. I call that course the gambling course. But well, what happens is the reliability group did a study on how reliable they felt that the Mercury spaceship was going to be, and he said, "You guys did a good job. We got 3 9s, so that's pretty darn close to 1." He said, "There's one problem though. You're going to lose 2 of the astronauts." And we said, "What? We can't do that. We don't work that way." So we had to add some more redundant systems. And for instance, on our autopilot, we had fly-by-wire, and that was it was a pilot stick. And when you did the motions that a pilot does in an airplane, it sends signals to the thrusters, and that's how he control the spaceship. John Glenn flew the whole flight with that crazy system. And then what we did to help get closer to a 1 is we put a mechanical linkage from that stick to the solenoid. So now if the power went off, we still had a way of controlling the spaceship. And all the systems guys had to come up with methods to do that kind of stuff. And the sequencing system Dean was responsible for. We had parallel relays and all kinds of crazy stuff to get that to closer to a 1. Well, we ended up at 5 9s. And so they said, "Okay, guys, we think we can get them all back."
All the redundancy that we built into the system really came into play in Gordon Cooper's flight.
Yeah.
They had a premature 0.05 G signal, and that 05 G signal really knocked out all 99% of the automated system. So everything past that point, which occurred in orbit, everything past that point had to be done manually. And
Let's take a couple other questions as we go through this.
Sure.
Considering the tragedy of Apollo 1, when you were first designing the capsules, was there any engineering discussions about fire danger or danger of pure oxygen atmosphere? Was that ever
Yes, absolutely.
Absolutely.
Yes, big
A lot of
Big big time.
And
discussion.
we had a little bit of difference.
Yeah.
We had a guy controlling the knob that let the oxygen go into that spaceship. We didn't have any automatic system. That's the thing that caused the death of Gus Grissom. There was a guy monitoring that system in Houston, and it would automatically increase the pressure if it went down. It was supposed to keep it at 5 pounds per square inch. And the guy who was sitting at that station in Houston, when he heard the term fire, should have shut that automatic system off. Because Gus dumped all the oxygen out and there wouldn't have been a fire. But nobody bothered with that thing because they were 1,400 miles away. And so when the pressure went down to 0, when he dumped it, it says, oh, I got to put some more oxygen in. And it kept putting it in.
Yeah.
Then that's what really fueled the fire, kept it going. Because when they're in space, that's the operation they do. If they have a fire in space, they dump the cabin's atmosphere. So without oxygen, you can't burn things.
We were all well aware of the dangers of pure oxygen atmosphere and designed to limit the possibility of a fire.
Yeah.
So, and that was both in Mercury and Gemini.
Yeah.
Let's take another question. We'll try to fire a few of these. We're nearing the end of our time.
I'm interested in whether you got interested in space, maybe engineering at the same time, at a young age. Did you wait till your college years and then be attracted through engineering into space work? Or did you have some kind of earlier introduction and interest in astronomy and space, or maybe just space, when you were in, let's say, pre-college?
Didn't have a clue
Education.
about space.
No, it didn't. There wasn't much in the engineering world, much discussion of it before then.
We were all interested.
Sputnik is what brought it out.
All interested a little bit in Buck Rogers, you know, the comic strip.
That thing.
And there were some novels that were written, I think, about going to the moon and so on. Those were always interesting, but it was way out there, you know, sci-fi stuff.
No education in the classroom?
No.
No.
Yeah, we all had to take physics, and so we knew a little bit about Newton's laws and
Yeah.
things, but they didn't discuss space.
No.
Today I volunteer my time at the 2 school districts at the very end of the astronomy class sessions, and part of that curriculum is space history, and so I go over with my flash drive and put a bunch of pictures up on the smart boards and give them a little discussions, and the kids all look forward to that one every year. But, that's one of my voluntary things I do.
I volunteered also in the classroom for 20 years. I just retired from my second job. 20 years retirement from that. But when we would talk to the kids about the Mercury program, they were more interested in what happened to Ham and Enos than they were with the astronauts.
All right, lightning round, 2 more questions.
As the Mercury and Gemini engineers, you are the first time that man has ever been in space. How do you feel of the upcoming Mars missions, hopeful Mars missions, to send a man and woman to space? How do you feel to see that the progression over time, the space exploration, man's exploration of space?
Oh, that's great.
Let's get a quick response on that.
The ultimate goal of getting a man or a human or a colony on Mars, I don't think will happen in any of our lifetimes, but eventually it might. But that's a real challenge, and to me that is similar to the challenge that we were facing. We didn't know what was going to happen and what could and could not be done, and at least they will have that advantage over us. But yeah, I think one of these days it might happen, but I don't think, well maybe, but I don't think we'll ever get 2 million people down to Cape to watch a launch again. And the world's attention is elsewhere, not on space activities.
And
Now, when
Congress,
Jerry said in our lifetime, you understand.
we were sure.
Because, by 2000, 2030 or something like that, we'll put a man on Mars, so many of you will have the opportunity to see that. We probably won't, or if we, we probably won't.
The geologist that's the professor over at Washington U that's been on the rover program for 10 years now. You know the original rover program, they only allowed 6 months for those to still be working because of the dust things that you have on Mars. And what they didn't count on was the dirt devils. They kept the solar array clean, and those things have been operating now for 10 years.
Yeah.
We went to a little Science and Suds meeting over here in St. Louis that the Washington University sponsors. And a gentleman that's the geologist from that program came, and it was really interesting. He showed us a picture of where the rovers were that he had just seen 15 minutes earlier. So that was pretty neat. But we're not going to get to Mars unless Congress coughs up the money. And so I was at another seminar. The head of the astronaut corps got a big award at Washington U, and I went to see it. And he said he doesn't think, he said it's always going to be putting rovers and automatic equipment on the moon. Now, when we were at that one meeting, the professor said that they have proved with their little laboratories that they have that there was life on Mars, that there was things that would grow. When the volcanoes were working 500 million years ago, the planet was warm and wet. And so they sort of have proved that there was a life cycle of some sort, but the scientific community will not accept the data because the little laboratory is too small. So we have to get a man on Mars to prove to the world that that there has been life on there.
Well, we're nearing the end of our time, and I'm going to take this question here, and then I think we have a question from one of our students. I don't want to miss that question, so we'll just keep our responses extremely brief.
Well, first of all, thank you very much for working 7 days a week that we can even think of going to Mars today. But I have one question. Gemini 8, what went wrong with the thruster, and what was it during your watch?
It was during my watch.
Everything was during our watch.
I was responsible for the even-numbered spaceships getting through the launch operations mode, and my system was all the fuel cell and the batteries and the sequencing system that Dean designed, and it was a manufacturing problem, not a design problem. And that was the second teaching job I had, because to solve that problem, we had to call all the shop people in and come up with a direct procedure on how they should wire those wires that go to the thruster. They had a protection from RF energy wire weave that went across the whole spaceship. All the wires went all down the length of the wires, and when they terminated it, they terminated that little shield so that the signal was supposed to get switched to ground to turn it on, but it was always grounded, and so once they turned the power on it, the thruster came on all the time. So I was responsible for Neil Armstrong's spaceship, number 8.
Oh, this is our last question over here.
Hi, I was just wondering, what do you think the most critical position in the modern age is for getting space science moving forward, going in the future? As in, do you think education is the most important, changing the political landscape, or research? What do you think is going to push us forward the most in the near future?
Well,
I think that there is a most important. It's all these programs, start back at Mercury, things have to be done. You have to pay attention to everything, so education.
Education is important for the whole world. Everything we do, we have to have education.
Research.
And let's see, probably being able to get it cheap enough to do. That's one of the most important things. And the guy from SpaceX is really working on that problem. I don't know how much it costs to build a rocket, but probably millions of dollars. And he's flown 6 of the same rocket and put 6 satellites into space. And boy, that is saving a lot of money.
this gentleman here that asked the question, you should put your money on Elon Musk. SpaceX will do it. I'm satisfied they will.
Well, it's been absolutely fantastic to have Maxwell team, these American heroes. They met the challenge. They got us into space. They're not done yet.
Thank you very much.